evolutionary maturity perspective. Table 13.2. An evolutionary maturity model scale for advanced civilizations. Type 0. A single-planet evolutionary immature intelligent species, still capable of self-extinction, has not reached the survival plateau on the species survival maturity model, and without any ability to migrate to other planets. Type 1. A multi-planet evolutionary mature intelligent species that has reached the survival plateau on the species survival maturity model, maturing beyond the point of self-extinction, and has successfully developed the survival-driven social, cultural, and technological capabilities to become a multi-planet species. Type 2. A multisolar evolutionary mature intelligent species that has reached the survival plateau and hence has matured beyond the point of self-extinction. One that has matured enough to use its multi-planet cooperation to become multisolar. Type 3. A galactic evolutionary mature intelligent species that has used the intersolar cooperation it developed to achieve multisolar status to populate its host galaxy. Type 4. An intergalactic evolutionary mature intelligent species. And Type 5. A universal evolutionary mature intelligent species. The difference between the evolutionary maturity model scale above and the Kardashev, Sagan, and Social Progress Index scales is that, whereas the latter measure a species' ability to innovate and prosper, the former recognizes that in order to do so, it must first be able to survive, and to survive, it must attain evolutionary maturity and thereby evolve beyond the point of self-extinction. It must first be able to develop a survival-first culture, one that places the survival of its habitats, of other species occupying those habitats, and of itself above its science, its technologies, and its prosperity. With the above in mind, how much of Homo sapiens' 21st century civilization can be repurposed for use in a world that wants to transition to a civilization guided by the evolutionary principles of maturity, species survival, and habitat sustainability? Even if 99% of our species wanted such a transition, would it be possible? How would we get from here to there? It would be surprising if such a transformation could occur, or even be attempted, if not precipitated by some cataclysmic event that completely disrupts, or threatens to disrupt, the very underpinnings of such a civilization, such as the coronavirus, unchecked, could be capable of doing. Given the history of Homo sapiens and its prior hominin forebears, few things have been better at doing that than habitat loss driven by climate change. It is not that Homo sapiens, over the brief 70,000-year period since leaving Africa, has not made massive species-wide transformations, but no such major transition has ever been voluntarily undertaken. Rather, they have been driven by species-wide existential threats. Leaving Africa in the midst of widespread habitat failures brought on by climate change was one such event, and our species has not been the same since. Climate change-driven habitat failure has been a significant component, if not the major reason, of most collapsed Homo sapiens civilizations. Many, too, have been driven by conquests at the hands of invading armies. Not much of how the Babylonians, Assyrians, Greeks, and Romans lived and managed their affairs, governed themselves, and traded form a meaningful part of how Homo sapiens live today. But for a few areas here and there, subsequent civilizations appear to start almost from scratch each time. None of these transitions from kingdom to kingdom, from civilization to civilization, appears to have been voluntarily undertaken. It is not unreasonable to conclude that if modern Homo sapiens, the last intelligent species standing, had to make such a transformation to survive, it probably would have to be driven by existential or massively disruptive events that strike at the very foundations of modern civilization. One such event could turn out to be a pandemic, such as COVID-19, if left unchecked, the collapse of capitalism or Western civilization. Another might be yet another world war. And, if all else fails, one can always count on good old reliable climate change. This time, however, most believe, even the Pope, was precipitated by Homo sapiens itself. It may well turn out that the global crises and chaos created by climate change, and partly predicted in simulations by climate scientists, rising sea levels, sustained and unbearable levels of heat in many relatively temperate regions of the planet, protracted droughts, devastating storms, and failing food webs, are evolution's final push to nudge humans up the remaining rungs on the species' survival maturity model, to drive Homo sapiens to abandon its current immature civilization and emerge at the far end more inclined to adopt and pursue an evolutionary mature one. Too often, potential existential threats such as climate change and habitat disruption have been viewed in a purely negative light. Yet in the history of intelligent species evolution, maturity, and survival, the incremental leaps that drive intelligent species to ever higher levels of adaptation, innovation, and maturity have often occurred in response to such threats and civilization-destroying crises. Indeed, it was just such an event that made way for mammals, and thereby Homo sapiens, when it took out the dinosaurs. Could it be that the climate change already in progress might yet again clear the way for a follow-on species, a mature version of ourselves, Homo sapiens 2.0, that hominin descendant that evolution might have been betting on all along? So, if Homo sapiens are unlikely to voluntarily transform and build a new evolutionary mature intelligent species civilization to survive, then, as prior hominin species have experienced when it was their turn on the species survival maturity model, evolution will undoubtedly once again provide the impetus that will force Homo sapiens to either make such changes or face extinction. As Frodo in J.R.R. Tolkien's Lord of the Rings had to get the ring to Mordor to save Middle-earth and the world of men, so Homo sapiens must either attain evolutionary maturity or go extinct. Such is the way of this evolutionary survival game of life. But unlike Frodo, who had Sam, Merry, Pippin, the Elven Kingdom, and Gandalf, Homo sapiens, the last in the genus Homo to carry this torch of life, has something much, much stronger on its side: evolution. If one had to hazard a guess as to what might turn out to be the impetus that drives Homo sapiens to choose maturity, a nuclear winter that could end Homo sapiens in self-extinction, an equally devastating future besieged and overrun by competing AI intelligence, or climate change-induced global warming, my guess would be climate change. It has been evolution's instrument of choice across geologic time for nudging evolutionary immature intelligent species on to greater maturity, to either adapt, innovate, mature, migrate, and survive, or go extinct. If so, climate change, some might argue the only non-self-extinction option of the three, might turn out to be Homo sapiens' last best hope. With climate change, a version of what our early forebears survived, there may still be hope for the kingdoms of men. What then are the chances that Homo sapiens might, despite its current trajectory, make that U-turn to survive, attain evolutionary maturity, and reach that survival plateau by maturing past the point of self-extinction. As pessimistic as some of the above might seem, if climate change turns out to be the impetus, it's not unlikely Homo sapiens could yet rise from the ravages of climate change to make that transformation and become the evolutionary, mature, intelligent species evolution set out to evolve. How? Simple, really. Because evolution might well have bet all of 4 billion years of evolution on planet Earth on just such an outcome. And I don't think evolution is planning to lose this round to the universe. What do you think? So, what might come after if a mature, intelligent Homo sapiens species survives? Should Homo sapiens succeed at this evolutionary game of life, it would likely have an opportunity to embark upon the most exciting phase of its evolution yet: mature, intelligent species extraterrestrial evolution. Having won the game of life, it would have the opportunity to partner with evolution to spread mature, intelligent species life across the galaxy and beyond. Homo sapiens would have truly evolved from an intelligent but evolutionary immature spaceman to an evolutionary mature intelligent bicentennial man. Were that to happen, viewed through our anthropocentric eyes, it would be easy to think Homo sapiens had against all odds won this multi-million-year evolutionary game of life. But that would be only part of the story. While this entire evolutionary effort required an evolutionary mature intelligent species to succeed, it may not have been about Homo sapiens specifically. There are those who think chimps today are at the evolutionary stage Homo sapiens were back in the Stone Age. Perish the thought, I can hear you thinking. Nonetheless, if evolution had to start all over with yet another batch of emergent intelligent species, the Earth is believed to have another 4 billion years before it begins to go sideways. If, however, Homo sapiens were to succeed, it is evolution that must be seen as the ultimate winner, regardless of which intelligent species makes it to the finish line. If Homo sapiens comes through, evolution will have successfully reached what appears to be one outcome among many. An evolutionary, mature, intelligent species will have been equipped with the ability to survive whatever darts of death and extinction a mindless universe might inadvertently hurl its way. This is evolution saying, "Never again." The tragedy of the dinosaurs' extinction will have been avenged. And that, my friend, is what your life and mine, viewed from an evolutionary outcome perspective, might be all about. In short, getting to this evolutionary outcome might be one reason, if not the only reason, we are here. The hominin species, our forebears, has survived climate change driven by the last ice age. But no prior hominins have ever experienced, let alone survived, a mass extinction or the global warming that now threatens to rival the temperatures that prevailed during the end Permian mass extinction. Now it's modern Homo sapiens' turn to survive this existential threat. But to survive, it must first avoid going extinct. The topic we take up next. Chapter 14. Extinction. A human universe without humans. Acting Captain's Log, Stardate 2258.42. We have had no word from Captain Pike. I therefore classified him a hostage of the war criminal known as Nero. Nero, who has destroyed my home planet and most of its 6 billion inhabitants. While the essence of our culture has been saved in the elders who now reside upon this ship, I estimate no more than 10,000 have survived. I am now a member of an endangered species. You might recognize the above as Spock's monologue in the movie Star Trek 2009, after Vulcan was destroyed. But what does it mean, and how does it feel when one's species becomes endangered, threatened with extinction? How does it feel, particularly when the threat is self-imposed? Spock did not have a choice, but today, Homo sapiens still might. If one knew catastrophe was near, the way the passengers aboard the Titanic knew that in 2 hours and 40 minutes, they would either be in a lifeboat or drowning in the cold waters of the Atlantic, would that awareness help focus attention on survival? You'd think so, yet it took a full hour before the first lifeboat was lowered that night, and with only 24 people in it, despite having a capacity of 65. Therein lies the problem with Homo sapiens today. Despite all the signs and warnings that a sixth mass extinction might be in progress, the threat of Homo sapiens extinction does not appear to have registered on many people's radar. To many, even if they did know it, it would still somehow seem like a long way off. Somehow, the fact that all our forebears, all prior hominin species, went extinct, some as recently as 30,000 years ago, doesn't seem to have raised even a little concern. Although threatened by extinction due to climate change 70,000 years ago, it is clear that our species has long forgotten what this threat means. Not since the end of the last ice age, when Homo sapiens had to migrate out of Africa to survive, has the population of our species fallen to what some scientists estimate to have been as low as 2,000 individuals. Now, 70,000 years later, with a population pushing 7.8 billion, our species, unlike Spock, has lost any memory or understanding of what it means to be a member of an endangered species threatened with extinction. There have been at least 5 similar die-offs previously, but this is the first in hominins history, and the first occurring with Homo sapiens' help. According to the World Wildlife Foundation, Earth has lost half of its wildlife in the past 40 years. Billions of animals have been lost as their habitats have become smaller with each passing year, a level of biological annihilation that represents a frightening assault on the foundations of human civilization, according to a study published in Proceedings of the National Academy of Sciences. In the words of Dr. Gerardo Ceballos, an ecology professor from the Universidad Nacional Autónoma de Mexico and a lead author of the study, the resulting biological annihilation obviously will have serious ecological, economic, and social consequences. Humanity will eventually pay a very high price for the decimation of the only assemblage of life that we know of in the universe. And we now know the form that price might take, as discussed in the chapter on sustainability. The key to Earth's ability to survive is its biodiversity, its species, ecosystems, and habitats. They comprise the life support systems of the planet. Earth's flora and fauna are not just food or materials to be leveraged for economic gain. They are an integral part of the planet's survival mechanisms, which together form a symbiotic, interdependent, and recurrent set of processes that drives Earth's ability to remain a living planet. The day Earth begins to lose its species, ecosystems, and habitats in sufficient numbers, as Mars may have done billions of years ago, Earth, too, will begin to die. Mass extinctions, it would seem, do not occur by accident, and this potential sixth mass extinction is most certainly not occurring by accident. If it makes anyone feel better, mass extinctions are not just sitting around waiting for some misguided intelligent species, like Homo sapiens, to come along and trigger the next one by setting off runaway global warming. the Earth has seen at least 5 major mass extinctions, all without Homo sapiens' help. Moreover, at least 2 scientists, David M. Ropp and John Sepkoski Jr., calculated that these major extinction events of the past 250 million years occurred periodically at nearly constant intervals of 26 million years. Mass extinctions appear to be an integral part of the universe's endless cycle of birth, life, and death. They can be caused by any of the inexhaustible life-extinguishing mechanisms the universe seems to have in its arsenal, as the solar system wends its way around the galaxy. From dinosaur-destroying asteroids to collisions with rogue planets, gamma rays, supernovae, and even solar systems swallowing black holes, to name a few. The issue here, then, is not one of if it will happen, and maybe not even when it will happen, but rather whether Homo sapiens will be prepared to escape it. It might well have been in response to this universal cycle, resulting in the extinction of life on Earth, across geologic time and even across the universe, that evolution evolved intelligent species with the potential to develop the ability to escape these existential threats from the universe and thus survive. From an evolutionary perspective, the entire reason for the existence and evolutionary journey of an intelligent species over geologic time might be to do precisely that, to either mature past the point of self-extinction and become capable of surviving the universe's existential threats, or face extinction, either one of its own making or one on the universal clock. There are innumerable reasons one might want to know what's coming, but the issue for 21st century Homo sapiens is not when a mass extinction will occur. As surely as the Titanic was going to sink in 2 hours and 40 minutes, mass extinctions will happen again, with or without our prodding. Extinction, however, for intelligent species like Homo sapiens, need not be inevitable. As discussed in prior chapters, evolution has gone to a lot of trouble to leave Homo sapiens an escape path, should it decide to take it. Much has been written about extinctions, some about the possible extinction of intelligent species, like Homo sapiens, elsewhere in the galaxy. Few, if any, however, have taken the point of view offered herein, that the events that drive intelligent species' survival or extinction, though seemingly random, might actually be integral parts of an evolutionary process to spur such species to mature and choose survival over extinction. If one potential evolutionary outcome is the emergence of an intelligent species with the ability to escape the universe's existential threats, then neither the species' survival nor extinction can be purely random, but rather the result of choices it makes throughout its journey through geological time, including when faced with such events. The evolutionary patterns and rules we examined in prior chapters seem to suggest that if Homo sapiens were to choose to follow these patterns and rules, it would at least avoid self-extinction, if not escape extinction altogether. If it chooses not to follow these patterns, Homo sapiens will go extinct. There is simply no ambiguity from an evolutionary survival patterns perspective. So if such survival-enabling patterns and rules exist, are found, and are followed, even in a universe of recurring mass extinctions, Homo sapiens can know what to do to escape and survive, but only if it so chooses. In preceding chapters, we explored the evolutionary rules and patterns evolution left to show intelligent species the path to maturity and survival. We also saw how survival of an intelligent species is inextricably bound to attaining evolutionary maturity, that point at which a species evolves past the point of self-extinction. In this chapter, we go on to look at issues surrounding intelligent species extinction. Should Homo sapiens fail to mature and survive, who wins, who loses, and for whom would Homo sapiens extinction be a big fat don't care? We go on to look at what extinction would mean for Homo sapiens, our entire species, and for you and for me as members of the species. What it could mean for the galaxy and the universe, what it could mean for evolution, and for other intelligent species that might have already survived past the point of self-extinction, or are, like Homo sapiens, still trying to get there. Finally, we ask, if Homo sapiens had just enough time left to choose and implement one change in its civilization that could significantly slow, if not completely halt, the seeming stampede to extinction, what should that change be? When one contemplates all that the Homo sapiens species has accomplished, and might still accomplish were it to turn itself around, it is easy to become mortified by the magnitude of what a loss human extinction would mean. But as mind-boggling as that is to contemplate, if one considers the potential loss, not only from a human perspective, but also from an evolutionary one, the magnitude of such a loss takes on truly galactic proportions. From this perspective, one can factor in the many species that might have survived had Homo sapiens attained evolutionary maturity and found a way to escape self-extinction and the universe's existential threats. We still don't know why it took nearly 4 billion years of evolution for the first intelligent species to emerge, nor has it gotten any clearer why hominins' evolution should have filled the niches left vacant soon after, geologically speaking, the extinction of the dinosaurs. But if humans were to go extinct, not only would the hopes, dreams, and evolutionary maturity and survival aspirations of Homo sapiens disappear, the entire genus, and possibly the first nascent intelligent species to evolve on the planet, and some would even say in the galaxy, would come to an end. So too would evolution's attempt to evolve, in response, an intelligent species capable of surviving what the dinosaurs couldn't. The existential threats the universe has used so successfully to extinguish life. Homo sapiens is the last surviving species, descended from a long line of hominins that began to evolve some 6 million years ago, all of which, except Homo sapiens, have gone extinct, some as recently as 30,000 years ago. If Homo sapiens were to go extinct, intelligent species evolution would come to an end, at least on planet Earth, and may or may not ever start again. If that extinction is due to one of the universe's existential threats, as the dinosaurs was, then the universe will have won. We also will have found the answer to Einstein's question and finally realize that the universe is definitely not a friendly place after all. From the perspective of some future alien geologist 100 million years or so from now, all that will be left of our time on this planet will be a paper-thin layer in the rocks. So says geologist Jan Zalesevich in his book, The Earth After Us, What Legacy Will Humans Leave in the Rocks? But we are still a long way from such an outcome, and hopefully there is still time to change course. Intelligent species have survived ice ages, but none so far has ever experienced, let alone survived, a mass extinction. If Homo sapiens are still an Earth-only species, when the 6th mass extinction's arc of death begins to encircle humans, it is highly unlikely any will survive. Few animals larger than a dog survived the Cretaceous Paleogene, or Cretaceous Tertiary, KT, extinction event that took out the dinosaurs 65 million years ago, and only 10% of the world's species survived the end Permian extinction, and none was a complex animal species. Will any survive this one? Will Homo sapiens survive the sixth mass extinction? How long does it take for a mass extinction to come on? How bad will it get? How quickly and how long will it last? What are some of the signs? What parts of the planet will be hit first? Is there any place to hide, as on the Titanic, to try to hang on as long as possible? These are questions not too many have begun to ask yet, but they will eventually. One way to begin to answer some of these questions is by looking at prior mass extinctions, in particular, the End-Permian mass extinction. There may be some pretty direct parallels between the End-Permian extinction and today, says Jonathan Payne, professor of geological and environmental sciences at Stanford University. Scientists have been updating their research on the End-Permian extinction, and an MIT-led team of researchers has been able to establish that the End-Permian extinction, also known as the Permian-Triassic extinction, or the Great Dying, which took place some 252.2 million years ago, and in which 90% of all marine life and 70% of terrestrial life disappeared, was extremely rapid. Massive die-outs occurred both in the oceans and on land in less than 60,000 years, a blink of an eye in geologic time, but nearly as long as the 70,000 years since Homo sapiens left Africa. The researchers also found that a massive buildup of atmospheric carbon dioxide coincided with the period, and likely triggered the simultaneous collapse of species in the oceans and on land. People have never known how long extinctions lasted, says Sam Bowring, the Robert R. Schrock Professor of Geology from the Department of Earth, Atmospheric, and Planetary Sciences at MIT. Many people think maybe millions of years, but this is tens of thousands of years. There's a lot of controversy about what caused the End-Permian extinction, but whatever caused it, this is a fundamental constraint on it. It had to have been something that happened very quickly. But while it took just a blink of an eye in geologic time, the full recovery of ecological systems following this most devastating extinction event of all time took at least 30 million years, according to research done at the University of Bristol. According to Sarda Sani, one of the researchers, and Professor Michael Benton at the University of Bristol, and published in Proceedings of the Royal Society B, our research shows that after a major ecological crisis, recovery takes a very long time. So although we have not yet witnessed anything like the level of extinction that occurred at the end of the Permian, we should nevertheless bear in mind that ecosystems take a very long time to fully recover. And the signs are becoming clearer that the End-Permian and a potential sixth mass extinction may have more than a few things in common. The more scientists learn about what may have caused the End-Permian, the more parallels they see to today's world. A bout of greenhouse gas-induced global warming, much like today's, set off a chain of events that culminated in oxygen-depleted oceans exhaling poison gas. Today, by burning fossil fuels, Homo sapiens are again releasing carbon sequestered long ago, and at a similarly rapid rate. Of primary interest to 21st century Homo sapiens is the sixth mass extinction, which is believed by some to have begun as far back as when the first modern humans began to disperse to different parts of the world, about 100,000 years ago, but really accelerated about 10,000 years ago when humans turned to agriculture. Over the last few centuries, humans have essentially become the top predator, not only on land, but also across the sea. Everywhere modern humans landed, native species became extinct shortly after. No other species in the past can claim such a distinction. Never before has one species remodeled the terrestrial biosphere so dramatically to serve its own ends. The correlation of other species' extinction to Homo sapiens' potential extinction is becoming clearer as more and more species die off. The loss of one species can have unforeseen consequences for many others, since ecosystems are connected by a complex web of interactions that we do not always fully understand, writes Washington Post journalist Sarah Kaplan in The Independent. The key to survival seems to lie in food webs, the complicated interactions one probably mapped out in middle school, that illustrate how species in an ecosystem get food and avoid getting turned into food. A stable food web can isolate a community from environmental disasters, even the loss of some species, and the best food webs are like a well-built building. Individual bricks may crumble or be removed, but the overall structure remains sound. It's not until something truly traumatic happens, the loss of too many species, or of a keystone species that alter the habitat and are indispensable to the survival of the ecosystem, such as corals, mangroves, beavers, or gray wolves in the Grand Canyon, whose removal allowed a prey population to explode, that the whole thing comes tumbling down. In a study published in Science titled Community Stability and Selective Extinction During the Permian-Triassic Mass Extinction, paleontologist Peter D. Rupnerine and paleobiologist Kenneth D. Angielchik recount the results of an experiment and their efforts to understand how species survived or went extinct as the extinction event unfolded. They looked back at 250-million-year-old fossils from the Karoo Basin in South Africa, a region known for huge game farms, and an excellently preserved fossil record, and reconstructed Permian food webs from before the mass extinction. Their findings offer some insight into the possible impact of disappearing species on the human food web, and how life deals with a crisis of monumental proportions. What they found was at once interesting and instructive. Even when faced with the initial phase of the end Permian mass extinction, when small animals were dying out in vast quantities, the food webs remained solid. Eventually, even the most stable food webs couldn't withstand 1,000,000 years of drought, wildfires, ocean acidification, and runaway climate change. After the food webs fell apart, individual species characteristics, the ability to burrow and hide, to withstand climate shifts or loss of food sources, and a heaping dose of luck were likely what set survivors apart from their doomed contemporaries. According to the World Wildlife Fund, Earth has lost half of its wildlife in the past 40 years. How many more wildlife, animals, plants, birds, marine, and insect species can Homo sapiens drive to extinction before the food webs that support its survival begin to crumble and eventually collapse? No one has worked that one out yet. At this point, says Rupnerine, modern food webs are still something of a mystery. In his book The Serengeti Rules, The Quest to Discover How Life Works and Why It Matters, biologist Sean Carroll shares useful insights about many food webs, the rules of the Serengeti, and nature as a whole. Carroll writes, "The food chain is subdivided into different levels according to the food each consumes, known as trophic levels in the food chain. At the bottom are the decomposers that decompose organic debris. Above them are the producers, the plants that rely on sunlight, rain, and soil nutrients. At the next level are the consumers, the herbivores that eat the plants, and above them the predators that eat the herbivores. Predator-in-chief, Homo sapiens, for the most part, seems oblivious to the workings of the very ecosystems upon which its survival depends." According to Dr. Richard Lampitt in a discussion with National Geographic, Phytoplankton are at the base of what scientists refer to as oceanic biological productivity, the ability of a body of water to support life, such as plants, fish, and wildlife. They are the foundation of the oceanic food chain. Fish, whales, dolphins, crabs, seabirds, and just about everything else that live in or off of the oceans owe their existence to phytoplankton, one-celled plants that live at the ocean's surface. As noted in a previous chapter, the loss of oxygen generated by phytoplankton because of increased warming of the oceans might pose a far greater threat to our species' survival than flooding due to sea level rise. At least 50%, and some think as much as 2/3 of the planet's total atmospheric oxygen is produced by ocean phytoplankton, and therefore, cessation would result in the depletion of atmospheric oxygen on a global scale. This would likely result in the mass mortality of animals and humans. In other words, Homo sapiens extinction. Homo sapiens behaves as though it believes it is not subject to any of the rules that regulate an ecosystem and the food webs it supports. For non-intelligent species, it's all about the food and who eats whom. For Homo sapiens, however, it's all about the money, and it seems willing to hunt, fish, farm, poach, and ravage an entire tropic level to near extinction and drive individual species, threatened or not, to extinction. The Serengeti rules make sense and are built into ecosystems and nature. But Homo sapiens has been living outside and apart from nature since agriculture became its de facto method of subsistence. Homo sapiens has become the cancer that's ravaging nature's ecosystems. Nonetheless, learning about food webs and what might drive their collapse would allow recognition of signs of an approaching human food web collapse. And should that occur, extinction couldn't be too far behind. As per Carroll, without sunlight there would be no plants. Without plants there would be no food for herbivores. Without herbivores there would be no prey. Without prey there would be no predators. Can one imagine a world without food? With time, I'm sure, following the food is sure to become much more important to Homo sapiens than following the money, and hopefully before it's too late. Despite our efforts to create buffers against the ups and downs of nature, just as in all prior collapsed Homo sapiens civilizations, survival requires healthy ecosystems for food, water, and other resources. When these begin to go, we will have all the signs we will ever need. As climate change worsens and global warming effects intensify, keep your eyes on the reduction of arable lands due to increasing droughts and rising sea levels, and on the resulting food shortages and mass migrations. So, how much longer do Homo sapiens have? And how quickly can the sixth mass extinction come on? While no one knows for sure, and no two mass extinctions are alike, if the speed with which the end Permian came on is any indication, Homo sapiens might not have too much time left to turn away from the practices driving this extinction. Are there some places on the planet that would be less impacted than others? Perhaps. Some scientists claim that even during the worst glaciations, or snowball Earths, survivable habitats, however marginal, would have existed on both sides of the equator through the 45th parallel. And, indeed, the fact that we are here talking about it indicates there must have been. Similarly, there are those who think there might also be parts of the planet in areas between the 45th parallel and the poles in either hemisphere that might be survivable even during intense. How intense? Global warming. Some of these might include areas in northern Canada, Siberia, Scandinavia, and some island nations like Japan. Others include countries such as Britain and New Zealand, and some tropical island areas like Taiwan, Hawaiian Islands, and the Philippines. But glaciations are not the same as mass extinctions. If prior mass extinctions are our guide, it's likely that no place will be safe for long. So even those might turn out to be brief respites. And if there were such places, imagine competing with even a tiny fraction of the 7.8 billion people trying to get to them. Just consider the reception being offered across the world to migrants from Africa and other parts of the world fleeing war, famine, or anything else. So, perhaps instead of packing a doomsday bug-out bag, let's turn our collective energies to helping our species turn itself around while there might still be time. Might something more be at work here? A larger picture, of which Homo sapiens' evolution, maturity, and survival, or extinction, are but a small part. What else might be revealed by zooming out from a close-up of the Earth to a full view of the galaxy? What else might evolution have been up to across the galaxy? And how might Homo sapiens' extinction look from that perspective? Is the emergence of intelligent species strictly a terrestrial affair, or has evolution been just as busy nurturing intelligent species elsewhere in the galaxy? If the spread of mature intelligent species across the galaxy and the universe is a potential evolutionary outcome, how might Homo sapiens' extinction affect this outcome? Scientists marvel at the strange coincidences and unlikely juxtaposition of events that led to the evolution of life, eukaryotic cells, multicellular organisms, and the 4 billion years it took for the emergence of intelligent species on Earth. But hardly anything is known about evolution's effort to jumpstart mature intelligent species across the galaxy. Yet that might turn out to be a story equally exciting and inscrutable, if not more so. Single-celled life, like bacteria, might be common across the galaxy, as some scientists believe. But whether evolution has actually set out to jumpstart intelligent species life on other planets across the galaxy remains unknown. Some scientists think, following the Great Filter theory, that other intelligent species might have emerged and gone extinct, perhaps of their own doing, or as victims of one of the universe's mass extinction events. If so, then evolution's efforts to jumpstart mature intelligent species life on other planets across the galaxy would have suffered a great setback. If there are other intelligent species across the galaxy also striving to attain evolutionary maturity and escape self-extinction, then might not the extinction of Homo sapiens impact the field of surviving intelligent species, just as the extinction of particular hominin species on Earth affected the eventual evolution of Homo sapiens? If evolution cultured a clutch of hominin species on planet Earth to find at least one that might attain evolutionary maturity and become capable of surviving the universe's existential threats, might it not also raise a clutch of intelligent species in other solar systems for the same purpose? But if Homo sapiens is the only intelligent species, the proto-intelligent species of the Milky Way galaxy, then might evolution be hoping instead for Homo sapiens to mature beyond the point of self-extinction and spread mature intelligent species life across the galaxy through interplanetary and intersolar migration? If so, Homo sapiens extinction may well mean the end of intelligent species, not only on planet Earth, but also across the galaxy, if not forever, then for a very long time to come, leaving what some have begun to consider a human universe without humans. However these questions are resolved, what emerges is a picture of intelligent life struggling to take hold and survive in a hostile universe, and evolution's untiring struggle to keep life alive. As noted above, intelligent species have survived ice ages, but none so far has ever experienced, let alone survived, a mass extinction. If Homo sapiens is still an Earth-only species when a mass extinction hits, it is unlikely humans will survive. Should Homo sapiens go extinct, it will not be the first intelligent species on Earth to go extinct, but it would definitely be the last hominin species, and potentially the last intelligent species on Earth to do so. What would this mean for Homo sapiens? If, like passengers on the Titanic, Homo sapiens somehow knew that it had a finite amount of time, say the 100 years the late Stephen Hawking estimated we had to become a multi-planet species, or risk extinction, what could Homo sapiens do? Would we even know what to do? If we did, would we be capable of doing it? Would we lose precious time debating the science behind the timeline, the way they wasted precious time before the first lifeboat on the Titanic was lowered, or the way we are still debating the science behind global warming predictions? Is it even possible for our capitalist economies, corporations, and governments to make the changes needed, or find the will to make them? And would they do it in time to make a difference? It was James Galbraith who once observed, "There is no reason to believe that the democratic decision made by the living, in the face of their present needs and desires, will be the decision that would maximize the chance of long-term survival. The unpleasant conclusion is that it is possible for a society to choose economic collapse." Hardly anyone wants to die, and hardly anyone envisages a time when all humans, all their family and friends, and all the people they have ever met will cease to exist. No burials, no goodbyes, no wall of candles and flowers, just dead bodies everywhere, with no one left to bury them. Who thinks about stuff like that? The passengers on the Titanic, that's who. More and more people today, too, are starting to think about stuff like that when they see what's happening to the planet around them. But there are few signs of anyone seriously thinking of lowering the lifeboats. Just as the passengers on the Titanic were at the mercy of the captain and his crew to take action to prevent the ship from sinking and make timely common-sense decisions to save lives, so too the overwhelming majority of our species are not in control of their own fate. And just as the passengers did not steer the Titanic into danger, not everyone is responsible for the destruction of Earth's habitats and species, and for placing humanity at risk of extinction. Most of Homo sapiens 7 billion has had little say in whether the species will go extinct or not. Indeed, the fate of spaceship Earth rests largely in the hands of less than 1% of humanity. Governments and their militaries, global corporations and their corrupt politician sidekicks, the super rich, and others whose only concern is their balance in numbered accounts in offshore tax havens and the state of stock markets. Like the Ferengi, a fictional extraterrestrial race from the Star Trek universe, whose culture is characterized by an obsession with profit, trade, and economic growth, who measured their progress in terms of gain, competitive advantage, and dominance, and who were willing to bribe and swindle unwary customers into unfair deals, sacrificing everyone and everything. So too are the 1% of Homo sapiens who occupy the roles of both captain and crew aboard spaceship Earth. Like wildebeests thundering across the Serengeti into the waiting jaws of monster crocodiles on the banks of the Mara River, so too the other 99% of our species stampedes on, fearful and somewhat aware of the dangers that lie ahead, but seemingly locked in by a system that renders them largely unable to do anything else. No wildebeest wants to be crocodile food, and no Homo sapiens wants to go extinct, but neither seems capable of changing course. But Homo sapiens are not wildebeests. Evolution made sure intelligent species, unlike wildebeests, can adapt, innovate, and change course when confronted with an existential threat. And we must change course if we are to avoid extinction. But can we? This is a subject we will explore in the following chapter. Earlier in this chapter, we asked that if Homo sapiens had just enough time left to choose and implement one change in its civilization that could significantly slow, if not completely halt, the seeming stampede to extinction, what should that change be? For many people, that one thing is unequivocally capitalism. For even more people, that one thing is a change from a culture that glorifies personal and corporate gain, greed, endless economic growth, profits and earnings, to one focused on habitat sustainability, Homo sapiens maturity, and intelligent species survival. Capitalism has, over time, become a cancer and has spread and metastasized into every nook and cranny of modern Homo sapiens civilization. By destroying Earth's life-sustaining habitats, ecosystems, and species, the cancer of capitalism is in the process of killing the very civilization it was supposed to enrich. It has been said that it is easier to imagine the end of the world than to imagine an end to capitalism. But things have changed, and the 99% are beginning to see through capitalist practices and realize that for Homo sapiens to survive, capitalism must die. Many of the 99% can see how the 1% have turned the Earth's resources into capital and placed a price tag on everything, including life itself. They remember that millions of their forebears were stolen from their homes to work on plantations as slaves. They see the displacement of Aboriginal peoples and the theft of their ancestral lands through conquests and barefaced land grabs, and today, ostensibly, in the name of conservation. Their ancestors endured these enclosures, the imperialism, warfare, and ecocide over the last 500 years that have benefited a very small segment of humanity, while displacing, immiserating, enslaving, and destroying countless numbers of people, animals, and plants, writes Ashley Dawson in his book Extinction, A Radical History. And yes, they see clearly too the attempts of bio-capitalists today to patent genetic material and privatize that which evolution gave so freely, attempting to turn living organisms into programmable manufacturing systems. It is simply incredible how capitalist philosophies and practices, that invisible hand, has hijacked the minds of our species. Like a species under the control of the Ferengi, Homo sapiens has been driven to wreak havoc across the planet, its habitats and ecosystems, its species, and on itself in the pursuit of economic growth and profits.